If you stepped outside on any of the last 3 nights across northern latitudes and happened to look up, there's a reasonable chance you saw something that most people only ever see in photographs. Green and pink curtains of light rippling slowly across the sky, a faint but unmistakable shimmer above the northern horizon that no streetlight or city glow can produce. The northern lights have been appearing over Scotland, northern England, and the upper northern states of the United States repeatedly this week. And tonight and tomorrow night, conditions are building for another appearance as a G1 geomagnetic storm makes its way toward Earth. If you have never seen the Aurora before, this weekend might be the most accessible opportunity you have had in months. And if you have seen it before, you will already know that once is never enough. The story behind what is causing this weekend's display begins not with Earth, but with the Sun, and specifically with a feature on the Sun's surface called a coronal hole. A coronal hole is a region in the Sun's outer atmosphere, the corona, where the magnetic field lines point outward and away from the Sun rather than looping back into the surface. Those open field lines act like a nozzle, and through them, a continuous stream of charged solar particles, mostly electrons and protons, pours out into space at speeds far higher than the background solar wind. When one of these high-speed streams is directed toward Earth by the Sun's rotation, it takes roughly 2 to 4 days to reach our planet, and when it arrives, it interacts with Earth's own magnetic field in a way that can produce geomagnetic storms, and, if conditions are right, visible auroras at lower latitudes than usual. That is exactly the sequence that has been playing out this week. A large coronal hole was facing Earth in the days running up to April 17th, and the high-speed solar wind it produced arrived over the following days and drove a period of elevated geomagnetic activity that brought genuine aurora displays to northern latitudes. The KP index, which is the global measure of geomagnetic storm intensity running from 0 at the quiet end to 9 at the most extreme, reached level 6, officially classified as a G2 moderate geomagnetic storm, during the window of April 17th and 18th. That G2 level pushed the aurora visibility boundary far enough south that it was visible across Scotland and northern England in the UK, and across northern US states well below the Canadian border. One observer at Lake Vermilion in Minnesota captured the aurora for 3 consecutive nights. The display was real, it was documented, and it was remarkable for April. Now, a new chapter of that same general solar activity pattern is arriving this weekend. The Met Office Space Weather Team, which provides the UK's official geomagnetic forecasting, issued a forecast on April 25th stating that geomagnetic activity is likely to be quiet to active, ranging between KP level 1 and 4 for much of April 25th and 26th. However, it specifically flagged a greater chance of G1 minor storm conditions, meaning KP reaching level 5 on April 26th due to the anticipated arrival of a glancing coronal mass ejection. A coronal mass ejection is a different type of solar event from a coronal hole stream. Where a coronal hole produces a relatively sustained high-speed wind that can last several days, a coronal mass ejection is a discrete eruption of plasma and magnetic field launched from the Sun during a solar flare. The SOHO spacecraft's coronagraph camera captured exactly such a blast on April 21st after a filament eruption, and that ejected material has been tracked since then on a trajectory that may deliver a glancing blow to Earth's magnetic field around April 24th to 26th. Glancing is an important word in that forecast description. It means the CME will not strike Earth's magnetic field head-on, which would produce the most intense geomagnetic response. A glancing impact means the interaction is more oblique, less energetic, and the geomagnetic storm it produces is expected to remain at the G1 minor level, rather than escalating to G2 or above. For aurora visibility, G1 represents the lower threshold of meaningful aurora extension to mid-latitudes. Under G1 conditions, the KP index sits at 5, which, in ideal circumstances, pushes the aurora visibility line to roughly 50 degrees of geomagnetic latitude. For the United Kingdom, that means northern Scotland is comfortably within the zone of potential visibility. And with very dark skies and a clear horizon, locations in northern England, northern Wales, and northern Ireland stand a chance of seeing something as well. For the United States, G1 conditions typically allow aurora to be seen from northern Michigan, Wisconsin, Minnesota, Montana, and similar latitudes, particularly in rural areas away from city light pollution. The Met Office was measured in its description of what viewers should expect. Aurora is expected to be at predominantly background levels through most of the weekend, with some slight enhancements possible on Saturday night into Sunday, and perhaps also Sunday night. Any visible aurora will likely be limited to northern Scotland and similar latitudes where skies are clear. That is honest, calibrated forecasting, and it is worth reading carefully. It does not promise a dramatic display. What it says is that the conditions are in place for an enhancement above background, that northern Scotland is the most likely viewing zone in the UK, and that clear skies are the non-negotiable requirement. For the US, NOAA's Space Weather Prediction Center has confirmed a G1 watch for April 26th, consistent with the glancing CME impact forecast, meaning the same cautious optimism applies to high-latitude U.S. states. Understanding how the BISA component of the solar wind works explains why Aurora forecasting even a few hours ahead can be uncertain. The BES component is the north-south direction of the magnetic field, carried within the solar wind and within a CME. When BES points south, meaning it is oriented opposite to Earth's magnetic field, the two fields connect and solar wind energy pours through into Earth's magnetosphere, energizing the auroral oval and expanding it to lower latitudes. When BES points north, the two fields deflect each other and the energy transfer is greatly reduced, limiting or shutting down aurora activity. The critical problem is that the orientation of BZ within an arriving CME cannot be reliably measured until the solar wind reaches the monitoring point at the L1 Lagrange point, roughly 1 million miles from Earth, which gives forecasters only about an hour of warning before conditions either switch on or switch off at the surface. This is why aurora alerts sometimes say a storm arrived, but aurora was not visible, and why nights that were not heavily forecast can occasionally surprise with brilliant displays. The BES is the wild card in every aurora forecast, and it is one of the most closely watched numbers in space weather science. The broader context for this weekend's event is worth appreciating fully. The sun is currently near the peak of solar cycle 25, the roughly 11-year cycle of solar activity measured by sunspot count and flare frequency. Solar cycle peaks, known as solar maximum, are characterized by increased frequency and intensity of solar flares, coronal mass ejections, and coronal hole activity. The most powerful geomagnetic storm in the modern era of space weather monitoring, the May 2024 event that reached G5 level and produced aurora across southern Europe, northern Africa, and the southern United States, occurred during the ramp-up toward the same solar maximum. That event reached KP level 9 on the scale. The current weekend's expected G1 event sits at KP 5, considerably quieter, but it exists within the same elevated period of solar activity that has made aurora displays far more accessible to mid-latitude observers across 2024 and 2025 than they had been in the preceding decade. For anyone in northern Scotland, northern England, northern Ireland, or northern parts of the United States hoping to see the aurora, this weekend, the practical checklist is straightforward. The most important factor is cloud cover, and that means checking the weather forecast for your specific location before committing to a viewing session. In the UK, the Met Office app and the Clear Outside app, which is specifically designed for astronomers and aurora chasers, both provide cloud cover forecasts at hourly resolution. For US observers, the NOAA hourly weather graph for your location and the Clear Outside website both serve the same purpose. A completely clear sky is ideal, but broken cloud can still offer meaningful views of an aurora display if the gaps are large enough and the aurora is sufficiently intense. For aurora specifically, thin cirrus cloud is much less obstructive than dense low cloud, so some cloud cover does not necessarily mean a total loss. Timing matters significantly. The aurora is most active during the hours around local midnight, when your location on Earth is facing directly into the incoming solar wind flow from the sun. For UK observers, that means the window roughly between 10 p.m. and 2 a.m. local time is the most productive. For US observers in the relevant latitude bands, the equivalent window applies. Getting away from artificial light is the same principle as for meteor watching. Even moderate suburban light pollution can completely wash out a G1 aurora, which is typically faint and visible, primarily in photographs, unless the BIS flips strongly south and the KP spikes towards 6 or above. Driving 20 to 30 minutes into genuinely dark countryside transforms what you can see, particularly for the fainter green glow that a G1 event produces. Northern Scotland's rural areas, the Northumberland Dark Sky Park, the Lake District, and the coastal headlands of Northern Ireland all represent excellent UK options. For US observers, any location away from major metropolitan areas in Minnesota, Michigan, Wisconsin, Montana, or the Dakotas should provide good dark sky access. Your camera will likely see more than your naked eye does, and this is one of the most rewarding aspects of modern aurora. Photography. Long exposure shots on a smartphone in night mode, or on a DSLR camera set to ISO 1600 to 3200 with a 10 to 20 second exposure, consistently reveal structure, color, and intensity in an aurora display that the naked eye struggles to register at low KP levels. Many of the most spectacular aurora photographs posted by observers in northern England and Scotland during the April 18th G2 event were captured by phone cameras that brought out vivid greens and purples in a display that appeared to the naked eye as a faint pale shimmer on the northern horizon. At G1 levels, using a camera is not just helpful. For many mid-latitude observers, it is the only way they will confirm they are seeing an aurora rather than just wondering if the horizon looks slightly unusual tonight. Space weather conditions change quickly, and the advice to keep monitoring applies here as firmly as it does for any developing storm event. The Met Office Space Weather page at weathermetoffice.gov.uk and NOAA's Space Weather Prediction Center at swpc.noaa.gov both update their geomagnetic forecasts continuously. The Aurora Watch UK service from Lancaster University sends email and app alerts when geomagnetic conditions reach the threshold where aurora becomes likely to be visible from the UK. For U.S. observers, the Space Weather Live app and NOAA's Aurora Viewline tool provide real-time KP tracking and visibility estimates by latitude. If KP climbs above 5 tonight, or tomorrow night, alerts from these services will tell you before you would notice anything looking out of your window, giving you the few minutes needed to get outside and get your eyes adjusted before the display either builds or fades again. The sun has been generous to mid-latitude aurora watchers this week. 3 nights of activity. A G2 storm over the weekend, confirmed displays from Scotland to Minnesota, and now a G1 watch for Saturday night as a glancing CME arrival combines with fast coronal hole winds to keep conditions elevated. It may not be the most dramatic aurora weekend in recent memory, but for anyone who has never stood under a dark sky and watched the northern lights move, this weekend offers a real and genuine opportunity to see something that reminds you, in the most vivid possible way, that the Earth is not floating in empty space. It is sitting inside a dynamic, energetic, and occasionally spectacular solar environment that puts on a light show when the conditions are right. Tonight and Saturday night, the conditions are pointing in the right direction.